Today's video is going to be about geometric sequences. We've learned about arithmetic sequences in the past, and in arithmetic sequences, they have a common difference between each term. So you add or subtract the same number every time. In a geometric sequence, this is a sequence in which the ratio between any two terms is constant. And that just means that instead of adding and subtracting, we are going to multiply and divide the same thing every time. And that is what the common ratio is. The common ratio is the numerical ratio between any two terms, and we will use the variable r to represent it. So let's do the first few odd problems together as an example. The directions say to determine whether the sequence is geometric, and then if yes, identify the common ratio and give the next three terms. So first we decide, is this geometric? And to do that, we are going to do 12 divided by 6. So this one divided by this one. That equals 2. So now we want to see if we multiply each term by 2, do we get the next term? And yes, we do. So yes, this is a geometric sequence, and the common ratio is this number that we found here. And then the next three terms will be 48 times 2, which is 96, and then 96 times 2 is 192, and then 192 times 2 is 384. So all three of these components should be part of your answer. On number 3, we're just going to keep repeating this process. So 10 divided by -2 is equal to -5. So if we multiply by -5 each time, does that work? Yes, it does. And then remember, r is equal to this number that we found, and then we just continue multiplying by -5 to find the next answers. So 250 times -5 is -1250. Then it'll be 6250 and -31,250. All right, number 5. We're going to do -1 divided by 4 to tell us what we had to multiply by. And that is going to equal -1/4. So then if we multiply everything by -1/4, does that work? And yes, it is going to give us the same answer every time. So r is equal to -1/4. And the next three terms, we're just going to keep multiplying by -1/4. And 1/1024. And that is our answer. All right. And then finally, number 7, we'll do -14 divided by -2. That equals +7. So if we multiply by 7, not on that one. Does that get us the right answer every time? Yes, it does. R will equal 7, and we will continue multiplying by 7 to get the next three terms. These get pretty big. All right. So those are our answers. Now, I didn't do any examples where there's a no. 2 of the even numbers have a no as an answer. So that means that whenever you do this part, if you were to multiply then by -1/4 like we did up here, you would not get the right answers. And so if it's not the same thing every time, then the answer is just no, it's not geometric, and you don't have to do any further work. So now we're going to talk about the geometric sequence formula. And that just means that we want to be able to find any term in a geometric sequence. And this is the formula we can use to do that. So it says the nth term of any geometric sequence can be found using the formula, daggone it, there we go, A sub n equals A1 times R to the n minus 1 power, where A1 is the first term. This stays consistent through everything that we're doing, and R is the common ratio. The directions on these examples say to write a rule for each sequence, then find A6. So what we're going to do is rewrite the formula first. Our formula is AN equals A1 times R to the n minus 1 power. So we need to find A1 and R because AN and N are supposed to stay in our formula. So A1 equals 1 because it's the first term. R is going to equal the first term divided by the second term. So R is equal to 5. So our formula is 1 times 5 to the n minus 1 power. But we want to write this as AN equals 5 to the n minus 1 because multiplying by 1 doesn't change our answer at all. So this is part of our answer. But then it also tells us to find A6. So A sub 6 would be 5 to the 6 minus 1 power, which is 5 to the 5th power, which if you type in your calculator gives you 3,125. And now we're done with this problem. So let's try number 11 together. Once again, we're going to start with our formula. AN equals A1 times R to the n minus 1 power. So we want to find A1, which is just the first term, and then R is the second term divided by the first term, which in this case is -4. So our formula will be 2 times -4 to the n minus 1 power, but we have to rewrite this as AN equals 2 parentheses -4 to the n minus 1. This is the way that you have to write it because if this is not in parentheses, you'll get the wrong answers. All right, then we need to find A6. A6 equals 2 times -4 to the 6 minus 1 power. -4 to the 5th power is equal to -1,024. And when we multiply that 2, we get -2,048. All right, we'll do number 13 together as well. We are going to have A1 equal to 135. And R is equal to the second term divided by the first term, which in this case gives us a fraction, and that's okay. We are going to get R equal to 2/3. So we're going to write our formula AN equals 135, and we're just going to start using parentheses, times 2/3 to the n minus 1 power. So to find A6, we just plug 6 in for n. 135 times 2/3 to the 6 minus 1 power. And 2/3 to the 5th power is equal to 32 over 243. And when we multiply that by 135, we are going to get 160 over 9, or 17.7 repeating. Now the next few problems are slightly different. The directions now say to use the information given to find the indicated value. So the first thing that we want to do is recall our formula, because we are going to use it and we're going to fill in everything we do know to solve for what we don't know. So like right now, we know that A1 equals 7. So I'm going to put my equal sign in here and put 7 where A1 goes. We also know that R equals 4. So we're going to put our 4 here. And then it asks us to find A sub 8. So that means that n has to equal 8. And A sub n is what we don't know. So we are going to simplify this to solve for A sub 8. Sorry, this is what we should have done. All right, so 7 times 4 to the 7th power is 16,384. And then 7 times that big number is 114,688. And that is your answer for number 15. So let's see what number 17 wants us to find. We have our formula, A sub n equals A1 times R to the n minus 1. We know that A1 is 13. So we have 13 times something. We've done that. A4 equals 4,459. So 4,459 is the number that's going to go out here when n is equal to 4. Okay, so n, A sub n. So we've used both of those pieces of information. Now our problem is we want to find A sub 3, but first we have to find the common ratio. So we're going to solve for that first. And the way we do that is first dividing by 13. And this is going to give us 343 is equal to R, and then 4 minus 1 is 3. R to the 3rd power. These 13s get to cancel, and then we get 343 on the other side. So now we are going to take the cube root of both sides. And these will cancel each other, so we're just left with R on that side. And the cube root of 343 is equal to 7. So now we know everything that we need to know to find A sub 3. So A sub 3 is going to equal A sub 1, which is 13, times R, which is 7, to the 3 minus 1 power. So we'll have 13 times 49, which is equal to 637. And the final problem we're going to do together is an application. So this says Jackson bought a brand new car for $38,000. If the car depreciates in value by 20% each year, what will the car be worth in 8 years? So let's write out our normal equation that we use and then see if we can figure out what pieces fit where. So it says he bought a brand new car for $38,000. So that would be our starting point, or our A sub 1. This was our first value. It started at $38,000. So we've used that part of the equation. Then, or of the problem, I'm sorry. It says if the car depreciates, so that means it decreases in value by 20% each year. So let's pause right there. It's going to decrease by 20% each year. So this is telling us about the rate. This is telling us about the common ratio. But that common ratio is going to be, we need to know what we can multiply by to get a decrease of 20%. And if you take a number, if we take 100 and multiply it by 0.8, we will get 80. And that is a 20% decrease. So we are going to multiply this by 0.8. And then it wants to know, so that's our 20% depreciation. What will the car be worth in 8 years? So we want to find A of 8. So we're going to have 8 minus 1 here. So then we have 38,000 times 0.8 to the 7th power, which is a really long decimal, but it's actually not rounded. It's just a big number. And then when we multiply those together, we are going to get $7,969.18. All right, that is all for today. Thank you guys and have a great day.